am going to just quickly check the video because there was some apparently some weirdnesses yesterday. Hi, and welcome to the stream. I am Rachel. I did plus weekend stream, and today we're going to be reading a paper from EMNLP. So, if you're unfamiliar with it, EMNLP is a conference. It's a little quiet. It is a little quiet. All right, let me see if I can fix that real quick. Oh, okay, that monitor. Okay, that looks like it's pretty good. So EMNLP is a conference. It's going on right now, and it is a conference put on by ACL, the Association for Computational Physics, which is the big scholarly organization for specifically NLP. And in NLP, conferences are the fancy venue where everybody wants to get published. And then this paper is from the main conference, and the paper that we read last week was from the NLP, the negative results workshop, which is happening today. Yes, today. Also, the NLP OSS workshop is also happening today. And Vincent and I and Tomas, I think, have a paper there. Bias. I'm so sorry. I don't remember who the third author on the paper is. I'm the third author. It's give me just a second. I'm gonna look it up so that I don't say wrong things. Also, I'll warn you right now, I am at 20% focus. So I think it's gonna be a little bit of an interesting stream in terms of how well I stay on topic. Tomas, yeah. Paper. The paper is template guided text generation for task-oriented dialogue. So task-oriented dialogue is the sort of thing you'd use a Rasa chatbot for. Hi Faiza, hi. Ooh, Yari. Who? I'm sorry if I'm saying that wrong, but hello. Task-oriented dialogue is the sort of thing that you would use a Rasa assistant for. You need to do something and you're going to use a conversation to do it. And template text generation is sort of what I recommend in general. One second. Excuse me. Is what I recommend in general, which is where you have the text that you've written and then you put in slots. So like you would write your bank balance is, and then that would be the template, and then you'd have a space for the slot with the amount of the bank balance, for example. And this paper is about that, and it's interesting because it's I would say not the like hi Herzon, not the like hottest topic in NLP right now. Definitely that's more on the neural text generation front, but again, I do not recommend it for chatbots. So we're gonna see what these folks have to say about it. It is by Mihir, possibly Kale, and Abhinav, Rastogi, possibly, both out of Google in Mountain View. That's in California. Abstract. Virtual assistants such as Google Assistant, which presumably this team works on or near, Amazon Alexa, and Apple Siri enable users to interact with a large number of services and APIs on the web using natural language. In this work, we investigate two methods for natural language generation using a single domain-independent model across a large number of APIs. So they have a single model that they're going to do a lot of different things, and they're going to use two methods. First, we propose a schema-guided approach which conditions the generation on a schema describing the API in natural language. Okay, so you write like a paragraph saying what the API does. Our second method investigates the use of a small number of templates growing linearly in number of slots to convey the semantics of the API. Generate utterances from an arbitrary slot combination. A few simple templates are first concatenated to give a semantically correct but possibly incoherent and ungrammatical utterance. A pre-trained language model, there's language modeling, is subsequently employed to rewrite it into coherent, natural-sounding text. Okay, so they have templates, they stick them together, and then they paraphrase them using some sort of language model. Given that it's out of Google, probably BERT. Through automatic metrics and human evaluation, we show that our method improves over strong baseline, is robust to out-of-domain inputs, and shows improved sample efficiency. Oh, interesting. So I'm not entirely sure what the schema is. It sounds like a description, like a database schema, but a schema for what the API does. And then there's this template measure. So I'm not entirely sure what the difference is going to be between these two methods based on that description. More centered. Virtual assistants have become popular in recent years. I'm just gonna say I hate this type of introductory statement. Like, natural language processing is increasingly widely used. Yeah, we know it's an NLP conference. I don't know. Maybe it's a little bit rude, but it feels like just like the percentage of papers that have this as their introductory sentence is just like needlessly high. I would rather you say what your assistant does right up front. That's my preference. Have become popular in recent years, and task completion is one of their most important tasks. These assistants help users in accomplishing tasks such as finding restaurants, buying sports tickets, finding the weather, etc., by providing a natural language interface to many services or APIs available on the web. Most systems include a natural language understanding and dialogue state tracking module. For semantic parsing of the dialogue history, we do that. My understanding of semantic parsing is that it is slightly different, and I am not being able to access the specific ways in which it's different right now. I'm not comfortable saying that Rasa does semantic parsing. I don't know that it does. This is followed by a policy module which interacts with the APIs whenever required and generates the actions to be taken by data by the system to continue the dialogue. In the end, natural language generation module converts these actions into an utterance, which is surfaced to the user. This bit is commonly used, but also optional. You can also just write your responses. Being the user-facing interface of the dialogue system, NLG is one of the most important components impacting user experience. I'm going to say the thing that is most frustrating for users when it's consistently gotten wrong, in my opinion, is the NLU. Like, if you get that, like, I didn't understand you, I didn't understand you, I didn't understand you, I didn't understand you, and the information isn't being extracted, to me, I think that's the most important bit for improving user experience. Personal opinion. Traditional NLG systems heavily utilize a set of templates to produce system utterances. Although the use of templates gives good control over the outputs generated by the system, important, defining templates becomes increasingly tedious as more APIs are added. So your system can do more things, you keep having to tell it what to say. Supporting multi-domain conversations spanning multiple APIs quickly grows out of hand, requiring expert linguists and rigorous testing to ensure the grammatical correctness and appropriateness of generated utterances. Okay, so what they're saying is if you have one assistant and you want it to be able to handle everything, like a Google Assistant, for example, or a Google Home or something like that, where you have your on-device assistant and then it's connecting to different skills or tasks. I don't remember what the Google ones are called. I think Alexa calls them skills. But like other pieces of software written for the assistant by outside parties. So how can you make sure that the text that is generated by the assistant based on these, third-party things still remains to be good? I would say that this problem in particular is not universal. If you are building like an assistant that does one thing for you and your company, probably not going to be as big of a deal. Blah, blah, blah. And by linguists here, they mean probably something more like translators or localizers, and not necessarily scientists who study language. Commonly, when people hire for linguists, what they are looking for is someone who speaks multiple languages and will translate for you. Consequently, data-driven generative approaches have gained prominence. So they're more flexible, they can do more things. If you need to do a lot of things, they can save you time. Such systems require much less effort and can generate utterances containing novel patterns. Meanwhile, with the rapid proliferation of personal assistants, supporting large numbers of APIs across multiple domains has become increasingly important. resulting in research on supporting new APIs with few labeled examples. Few-shot learning, like GPT-3 calls itself few-shot learning. To this end, generative models pre-trained on large amounts of unannotated texts have been increasingly successful. Okay, so I would say they've been successful in research. I don't know that that's necessarily the default of really anyone who's developing assistants commercially right now, but I would, I'd like to know if I'm incorrect about that. In this work, we address the challenges of joint modeling across a large number of domains and data-efficient generalization to new domains and APIs for NLG. Our contributions are the following. So modeling, having a single model that can cover a large number of domains. Domains are in task, as we discovered a couple weeks ago, specifically for goal-oriented dialogue like this, a domain is a task. So like buying movie tickets or renting a flat or ordering jelly beans, whatever it is that you're doing. We propose two methods for zero-shot and few-shot NLG. Our first method, the schema-guided NLG, represents slots using their natural language descriptions. So these would be like objects. These slots. It's just the way that we use it in Rasa. Our second method, template-guided text generation, T2G2. No, wouldn't it be TG2? Right, because T2G2 would be TTGG, which is not what that is. It's TG. It's not relevant. This is just what they are using to refer to this particular system. It doesn't matter what the acronym is. Employs a simple text-based representation of system actions and formulates NLG as an utterance rewriting task. Figure 1. All right, let's go check out figure 1. So here is their overall architecture of our proposed template-guided approach. T5 is a transformer model. 1. Is that a Google model? Could have sworn it was out of 10 cents. I'm wrong about that. Overall architecture of our proposed template-guided approach. I warned y'all, my focus is woohoo. The policy module outputs a set of actions in response to the user utterance. Okay. Simple templates convert each action into a natural language utterance. Template-generated utterances are concatenated and fed to a T5 encoder-decoder model, citation to T5. The model rewrites it to a conversational response surfaced to the user. So these are the things that the assistant has been like, hey, this is what we should do. Offer intent, reserve restaurant. So offering to let someone reserve a restaurant, and then telling them about the price range, and then telling them about the form. Would you like to make a reservation at a restaurant? It is an expensive restaurant. Its rating is 4. And then that's all fed through this, string to string transformer model, and out you get, it is a fancy restaurant with a 4-star rating. Would you like me to reserve a table there? I don't know that expensive and fancy are synonyms here. Usually fancy restaurants are expensive, but there are many restaurants that are, certainly in Seattle, expensive without being fancy. So I would expect, being told that something was a fancy restaurant, there might be like dress code requirement, and I don't think that that is implicit in this expensive rating. I don't love this paraphrase. I feel like someone might get the wrong impression of the information that was originally offered by the assistant because of the way that this is paraphrased. I don't know, maybe they'll talk about it a little bit more, but given that this is their like cherry-picked example of how good their system works. Oh, okay, 2. We present the first NLG results on the schema-guided dialogue dataset. Not familiar with this dataset. Rastogi et al. 2019, which exceeds all other datasets in scale. That's quite the claim. Providing a total of 45 APIs over 20 domains. I'm assuming that they're saying that this is the largest schema-guided dialogue dataset. While the current state-of-the-art pre-training based methods struggle to generate generalized to unseen zero-shot APIs, our proposed methods are robust to out-of-domain inputs and display improved sample efficiency. Okay, so this is like a population of APIs, and they're saying what makes it large is that there's a lot of different things that the assistants want to be able to do, and that their method works well across different things. I guess I can see situations where you might want to do this, like if you're just for example a banking app. If you want, like, you have a credit card and that's one thing, and then you have your banking account and that's another thing, and they have separate APIs because you know, like banking databases are tend to be very legacy. Aviation databases tend to be very legacy. I guess I could see that as sort of a counterpart. I just don't think that I personally have talked to anyone who has this like particular need when they're building an assistant. But I guess that could be because the like sort of people who would build a Rasa assistant wouldn't necessarily do this, I guess. I don't know. Interesting. 3, we conduct an extensive set of experiments to investigate the role of dialogue, history, context, cross-domain transfer learning, and few-shot learning. We share our findings to guide the design choices in future research. So does what the person said previously matter? So I'm guessing that they're going to feed the whole conversation into the transformer rather than just the templates. Cross-domain transfer learning. So if I learn to order pizza really good, does that help me open a bank account? And few-shot learning, can I get away with just sharing a few examples? Which does seem to work particularly well with transformer language model to sort of warm up the model, but yeah, I guess we'll see what they say. Related work. Natural language generation. Okay, levels are still good. Natural language generation from structured input has been an active area of research, facilitated by the creation of datasets like Wikibio, ET, doing that's end-to-end challenge, WebNLG, and MultiWAS. It is interesting to me that the oldest citation here is from 2017. I guess they're arguing that a lot of people work on this, but this is, I would say, like, has been an active research area since the 60s, right? It's a very well known, lots of depth of literature. Neural sequence models have been extensively used in a variety of configurations for NLG and dialogue systems. Wen et al. 2017 proposes a two-step approach. First, generating a delexicalized utterance with placeholders for slots, and then pre-processing it to replace placeholders with values from API results. Whereas Nayak et al. Highlights the importance of conditioning responses on slot values. So this one would be like the Mad Lib approach, where you take out the words and replace them with, you know, your bank account balance is 500 euros or whatever, and then changing bank account to, you know, account with institution, and then 500 euros to be amount of money. And then plugging in API values, and then this other one suggests that you need to condition responses on slot values. So you have the slot values during generation, I'm guessing? And given the dates on those papers, I'm guessing probably that those were not with transformers. They were probably with bidirectional LSTMs with attention, if I had to guess. Sequence-to-sequence architectures directly converting a sequential representation of system actions to a system response are also very common. Okay, so sequence-to-sequence could be, I mean, that's like a whole class of models. Transformers are sort of the most recent architecture that people use for those, but they're a variety of things that you could do. And like this 2015 and this 2016 paper are almost certainly not going to be transformer papers since the paper came out in 2017. Domain adaptation and transfer learning on low resource settings have been extensively studied problem, citations, with recently released datasets like SGD and Fewshot WAS providing a good benchmark. Meanwhile, language models pre-trained on large amounts of unannotated text corpus have achieved state-of-the-art performance across several natural language processing tasks. This one's the BERT model. One's... I don't remember. Anyway, this is just like a selection of transformer language models. Yes. Okay, yeah, that's the GPT-2 paper, I think. Back up we go. I do like that they have the related work at the front. I think this is a good way to contextualize this, but if I were reviewing this paper, I'd be like, hey, you should talk about like when people started studying this problem, which was well before I was born. Including natural language generation, citations. Our template-based approach bears similarities to Sentence Fusion, 2005, and prototype-based text editing, citations. However, none of these work tackle text generation from structured data. I feel certain that there are papers that do this that are from before the year 2000. I would eat a hat if that was not the case. But yeah, you know, you're limited in space here. But yeah, I would like to see a little bit more time depth in their discussion. Although I will say, there were some fairly early citations, like 2005, a couple from like the early 2000s, but definitely people have worked on this before, unless they're saying specifically with neural models, in which case I would ask that they try that. A model. For a given system dialog turn, let A equal S equals I1 be the set of actions. Okay, so A is the actions which are produced by the system, where A is the total number of actions for this turn. Okay, so this is like the system, all the things that the system is doing before the user is expected to respond. Each action consists of a single dialog act, DI, representing the semantics of the action. That's interesting. So the way that we talk about actions at Rasa, they do not necessarily have to be dialogue acts, right? They can be things that the assistant is triggered to do. That would be like execute some code, but you wouldn't necessarily have to communicate back to the author or the user at all times. Along with the optional slot and value parameters, S and V respectively. So slot would be a variable you want to keep track of over the course of the conversation, and that would be like the key, and then the value is what the slot is, I'm guessing, based on their description. For example, inform, request, rec more, and request are some of the dialogue acts defined in the SGD dataset, which are used for informing the value of a slot to the user, asking if the user needs some other help, and requesting the value of a slot from the user, respectively. So this slot is asking if the user needs more help. Wait, these are slots? No, these are dialogue acts. Yeah. Okay, so these are things that the assistant will. That's a sort of opaque variable name. But they didn't. These authors didn't come up with it. It's from this this other data set. Some acts like inform require both the slot and value parameters, whereas acts like request require the slot parameter only, and acts like rec more need none. So here I'm asking for the slot by name. Here I'm telling somebody, hey, here's a slot, here's what the value is. And here I'm just like, do you need help? Some datasets allow multiple slot value arrangements for a single act, but such actions can generally be converted to the above representation by decomposing them into multiple actions for the same act, each containing exactly one slot value pair. Yep, that's definitely a way to do it. The goal of NLG is to translate A to a natural language response with the same semantic content. To this end, we first convert the set A into a sequence. Then we fine-tune a text-to-text transfer transformer, T5, for FEL 2020 model, which is pre-trained sequence to sequence transformer to generate the natural language response using the sequence as input. What I know about T5 is that it is very large. Now we present 3 different models for converting A into a sequence, the last 2 being our contributions. They are also summarized in figure 2. All right, 3.1, naive representations. God, it's very quiet today. I keep checking, like, has anyone said anything? The approach uses the most basic representation of actions, similar to that used in most prior work citations. Canonical representations of each action, action slot, or action slot value, depending on the parameters present in the action, are concatenated together to obtain a sequence representation of A. So big A can have lots of stuff in it. An A or an alpha? That's an A, right? I'm calling it A. If it's an alpha, just substitute the right word in your head. Although this representation is simple to obtain and gives state-of-the-art results for several data-to-text transfers, it suffers from 2 drawbacks. The sequence representation that they just talked about above. Okay, so they're saying we're not going to be using it. Okay. 1, semantics. The representation doesn't convey much information about the semantics of a slot. Consequently, the model may need a larger number of training examples to identify the semantics of a slot from its usage in the system utterances in the training data. I think when they say semantics here, what they mean is a like a vector representation for the word from like some sort of vector semantics embedding approach. You could absolutely add semantic information. Like you could concatenate like WordNet to this and get like structured semantic representations. Representation bias. This representation is very different from what the encoder has seen during the pre-training phase, which is natural language text. As a result, the representations learned during pre-training may not transfer well. Ping et al. Mitigate this by conducting additional pre-training using large-scale annotated dialogue datasets. While this method is effective, a large in-domain corpus may not always be available. Okay, so they're saying you shouldn't just concatenate your slots and tell them to the user, because when that's not going to get you a vector representation that you can use for paraphrasing, I guess is what they're saying. And also it's not going to sound very natural, I think, is the other thing that they're saying. So it's sounding a little bit it might sound a little bit stilted, like in this example here, right? All right, so this is the existing approach, and they're saying that those are the issues with it. And then these 2 methods they are proposing, so the schema-guided representation. Recent work on low-resource natural language understanding tasks have used natural language descriptions of slots. So like what information is in this conversational variable, I guess you could call it. These descriptions are easy to obtain, directly encode the semantics of the slot, and have been shown to help when in-domain training data is sparse. While description-based representations have become popular for tasks like spoken language understanding and dialogue state tracking, they have not yet been applied to the natural language generation task. So are they going to get these from like the API documentation, or are they going to be writing them by hand? Because if you're writing them by hand for all of your slots at some point, I don't know that that's less work than writing templates, you know what I mean? I'm sure they'll talk about it. We propose an extension of the naive representation by replacing the slot names with their natural language descriptions. The action representations, as illustrated in figure 2, are action, a description of the slot, action of a description of the slot with the value, where desk C represents a natural language description of slot S. This solves the first drawback of the naive representation mentioned above. So where you don't get this, like the slot name is a variable name, right? It probably doesn't actually have, you know, a vector representation that we can get from a pre-trained model. Okay. And then template guided representation. So this is also something that they're working on. We solve the representation bias problem. Another very strong claim. Solving and proving are both words that I would generally avoid in writing scientific literature, because you gotta argue for that. In math, like solving for something is like a specific thing that you do. It's a pretty strong claim for an engineer. I know it's nitpicky, but grad school helps you learn to pick nits, I guess, with research papers particularly. We solved the representation bias problem by converting the set of action output by the system into a natural language utterance. So you have your templates, and you, I'm guessing, paraphrase them using T5. We employ a technique similar to that used by Rastogi et al. 2019, where simple utterances are generated using a minimal set of manually defined templates. Specifically, as shown in Figure 3, we define one template for each system action. The representation of A is obtained by concatenating the corresponding templatized representations of each action in A. So A is a list of actions, you get the templates for each of those actions, and then you paraphrase them. So let's look at Figure 3. Have we looked at this one yet, Figure 2? Oh, no, we haven't looked at Figure 2 yet. Okay, so here we go. So an example showing the representation of system actions utilized by the three schemes. The template representation is generated by concatenating sentences obtained from two templates, which are inform, restaurant, $X. How about restaurant, $X? And inform cuisine, $X. The restaurant serves, $X food. Okay, so this is the sort of computer readable representation, and this is a natural language representation that I'm guessing that they are just writing by hand. That doesn't look like an API description to me. I guess it depends on the documentation for the API. So the naive would be inform the restaurant OPA, inform cuisine Greek, schema guided inform, name of restaurant OPA, inform type of food served Greek, template guided, how about the restaurant OPA, the restaurant serves Greek food, and then the ground truth, OPA is a nice Greek restaurant, how does it sound? I wonder where the ground truth is coming from, because this is not in any of these representations of the restaurant is nice, right? And you could imagine that being something that you have maybe some sort of rating summarization, or I don't know, like the health co rating or something. But that is additional information that is not found in any of these computer readable formats, right? And then Figure 3, example templates for ride-sharing API. Parameterized templates are defined for actions which contain a slot value. So notify success and goodbye. Your ride is booked, a cab is on its way. Have a safe ride. So these are for the booking process. Request destination, where are you riding to? Request shared, are you comfortable sharing the ride? Confirm destination $X, you're going to place. Inform fare $X, your ride costs dollars. Inform seats, your cab is for riders. Okay, so this is just sort of the way that the templates would be written for each of these things. Again, I feel like this has to be human written. I mean, so if you're having humans write templates, what you're getting from the paraphrasing is a more natural sounding utterance that might subtly change what you're telling the user, right? Like that example with like expensive versus fancy restaurant. They're not necessarily the same thing. Yeah? Okay, well, I'm sure they'll talk about this in more depth. Note, our focus here is not to generate conversational and grammatically correct utterances, but to have a simple representation of the actions, which can be rewritten by the model into a natural and fluent response. Hence, we do not need to cover all edge cases typically required in template-based methods, handling of plural, subject-verb agreement, morphological inflection, etc. Okay, so here they're saying, like, it's easier to write these templates because we don't have to care about the output language sounding good because we're going to run it through this transformer, and only need to define a small number of templates. For most APIs, this amount is around 15 to 30 templates, which can easily be written by the API developer. Sorry, the thing I'm thinking about here is okay. So they're saying that the benefit here of using this transformer is that you don't have to spend time writing things that sound good and natural to send to your users. You can just sort of like write them off the cuff. Couple of assumptions here. So one is that the developer speaks the language of the assistant is using. Another is that this your transformer model is going to cover the language that's working here. And another is that it's going to be, you know, more time and cost effective to use this really big model over maybe writing some rules to make the template sound good, right? Like there's definitely, particularly for morphologically rich languages, there's definitely like software tools that can make, you know, handle agreement things and correct them. Okay. So I guess like this feels like the approach that you would focus on me. Thank you. This sounds like the approach that you would use if you were just like hell bent on using transformers. Like, oh, I gotta use this big language model. And I don't know that it's necessarily going to be a universal approach. They're also not claiming that. I don't know. I should keep reading. I only need to define a small number of templates. So they're saying it's less work. You don't need to have somebody who actually like speaks the language good to carefully write templates that work good, and maybe, you know, fit the personality of the assistant and match your business voice and, you know, use the formality that you want your assistant to use or all that sort of stuff. It should just be handled by the transformer. We'll see about that. The actual number varies depending on the number of slots and intents supported by the API. Some special slots like date, time, and price are formatted using special rules, which can be reused across APIs. For example, we can convert time, date, and price. We call this step value paraphrasing. Since this method relies on a combination of templates and transfer learning from language models, we named it template-guided text generation, and then this abbreviation that I don't like for reasons I mentioned. T2G2. Experimental setup. We conduct a set of experiments to compare the 3 system action representations presented above. We also evaluate NLG in few shot settings and investigate a few other aspects of the SGD dataset. In each of the experiments reported in this paper, we start with the pre-trained T5 small model. 3. List. Oh, it is out of Google. Okay, that makes sense. It has 6 layers each in the encoder and decoder with a total of around 60 million parameters. The model is then fine-tuned, so the small model has 60 million parameters. The model is then fine-tuned on the corresponding dataset using a constant learning rate of 0.001 and batch size of 256 for 5,000 steps. The checkpoint yielding, the highest blue score on the development set, is picked for each reporting test set results. During inference, we use beam search with a width of 6 and a length penalty of alpha equals 0.6. So just parameters that they used. Action representations. We compare the different methods of action representations in MultiWAS 2.0, the cleaned version of the ETE restaurant corpus, and the schema-guided dialogue dataset. The SGD dataset features a large number of domains and slots, and the presence of multiple APIs per domain makes it a representative of practical scale-related challenges faced by today's virtual assistants. Furthermore, as opposed to the other two datasets, its evaluation sets contain many domains, and consequently slots which are not present in the training data. Okay, so they're saying that this very general system should work for places where we're trying to have our assistant handle pieces of information it's never seen before. Furthermore, as opposed to the other two data sets, its evaluation set contains many domains and consequently, we just read that. Even for domains shared between the training and evaluation sets, the evaluation sets contain additional slots in some cases. This focus on zero-slot generalization, so I haven't seen any of these slots or domains, but I need to still handle them, to new domains and APIs makes SGD more challenging than existing NLG benchmarks. Table 1 compares these data sets. So ETE, MWAS, and SGD, and the point is just that this one is bigger and has more things that you haven't seen. Automatic evaluation. Following prior work, we use BLUE and slot error rate as automatic metrics. SER represents the fraction of generated text where at least one slot was not correctly copied from the structured data. Since this metric relies on string matching, we cannot use it to evaluate binary slots like has live music. Its exact match nature also prevents it from identifying paraphrases of slot values, e.g. expensive and costly. For ETE, we use additional metrics in prior work for this benchmark: NIST, Rouge L, Meteor, Cider, and Blue. So these are, only one of the data sets you use these for? So these are a variety of alternatives to Blue. So Blue is a measure of, it's basically a measure of overlap between human-provided translations and a machine translation, and it's specifically designed for measuring corpus-level machine translation. Whether or not it's a good metric to use for NLG analysis is kind of an open question. It's common for people to use it, but it's not necessarily universally accepted as not problematic. You know what I mean? And having a good Blue score does not necessarily mean that a human would like what you put out in terms of language that you've generated. That makes sense. A reference to a table. Nope. Okay, fantastic. Excuse me. MultiWAS and ETE. Table 2 lists results on MultiWAS and Table 3 on ETE. We train separate models for each data set. Okay, so that you're not using the training data from one data set to do better on the other data. On both data sets, T2, G2, and Schema are comparable to the state-of-the-art naive approach. We note that the SER score on MultiWAS is slightly worse in comparison with SGPT, as CGPT generates 5 predictions for each input and then ranks them based on the SER score itself. On the other hand, we generate a single output on which SER is evaluated. Okay, so they're saying that this other model, which I'm guessing is out of OpenAI, could be wrong about that, is generating 5 predictions and picking the best one based on the score. Obviously not going to work when you don't have that score beforehand. And they're saying we just generate one output and then we evaluate based on the output that we generate. Overall, the results indicate that with enough annotative data, the naive approach is enough to attain good performance. Both datasets are large and feature limited variety. That's it. Zero-shot and few-shot settings offer a greater and more realistic challenge, and we explore those settings next. The SGD dataset, which spans 20 domains, enables us to study those settings. So, you want to be high, SER rate, error rate, you want to be low. That's very surprising that for the naive approach, the error rate on unseen things is lower. And for schema, wait, am I confusing what seen and unseen are? These are things that have not been seen previously, I'm guessing. And that's what it is for P2, G2, that the unseen error rate is lower as well. Oh, interesting. But it's higher for, this is a very surprising result to me. The error rate is higher on things it hasn't seen, on things it has seen before than it is on things it hasn't seen. All right, let me. All right. Super helpful, AutoMod. It let the spam through and block the question. What are your preferred metrics to evaluate NLG? Honestly, I like human evaluation. I know it's more expensive, but if you care enough to put the time in to build custom NLG, then you should care enough to make sure it works, right? Yeah. Specifically for anything where people are going to be interacting with this directly, there's no way to get around human evaluation. There's no way to get around your experience studies. If you don't do them, it will be bad no matter what. That's not fair. The likelihood that if you do not get human evaluation, you will have a model that has, you know, good numerical performance on whatever metric it is that you pick, that's calculated automatically, but a poor user experience is too high for me. Yeah, also this is wild. Why are all of these things doing better on things that they haven't seen that they have seen? I'm wondering if this is an error in this table, right? Because things that you haven't seen should be harder than things that you have seen. All of these. Question mark? You're writing in the margins with my mouse. All right, so what about few shot and zero shot? The ideal NLG model should be able to handle domains it was not exposed to during training. The SGD dataset, which features unseen domains in the evaluation sets, lets us assess the zero-shot capability of NLG systems. We report results in Table 4 on two test sets. The seen test consists of domains that were seen during training, while the unseen consists of brand new domains, aka the zero-shot setting. Okay, so I was not incorrect about what I was interpreting those rows as. Odd. First, all models exhibit low SER scores in both seen and unseen domains, with the template approach being the lowest. So they're saying that we don't have a lot of errors. Using the template means we had the least errors. This suggests that pre-trained language models are adept at copying, and this skill also generalizes to out-of-domain examples. I'd agree. Yeah, I think I agree that neural language models are pretty good at copying, so I buy that argument. Did we look at Table 3 yet? Oh wait, these are the SGD results. No, it makes sense. They have to be the SGD results, right? Copy refers to a trivial baseline comprising of a template-based input representation and has 0. Okay, wait, let's go back. I looked at the wrong table. This is on E2E and this is just on E2E. Where's the multi-was? Okay. So let's go through and look at the actual. I was looking at the tables out of order. My apologies. Why is NLG flagged as a term? Jildan says it makes a lot of sense. However, when building the NLG system, it might not be feasible to use human evaluation. Can metrics give you an idea whether or not you're moving in the right direction? That's a good question. I mean, I think they can give you a very lossy approximation. But I would also say if you don't have, I don't know, my general personal stance towards NLG and particularly neural NLG is kind of honestly kind of similar to facial recognition. Like, why? What problem is this solving, and what are the trade-offs? Because I think that I think about a commercial setting. I don't want to, say things that are factually incorrect, right? And using neural NLG makes that difficult. And if we look at this table, okay, so this is the slot error rate, right? How many of the slots did we just straight up get wrong? And the answer is like at least some for every method except this template-based input representation, which I realize is like not exciting, but you're also not lying to people, or you're not like missing information that they need. And I don't know that like slightly more fluent sounding output and not hiring a conversational designer is worth that, Like, so this is the fraction of generated text where at least one slot was not correctly copied from the structured data. Fraction? Wait, hold up. Does this say more than all of the slots are got wrong? I'm confused by this table. I continue to be confused by this table. Okay, so the slot error rates, what's the range on, what's the range on this? Lower is better. Obviously, you want 0. Multi-was. So blue score, higher is better, but it's a little bit of a questionable score. In any case, says overfitting. Wait, the fraction. Let me plot error rate. Fraction of generated text where at least one slot was not correctly copied from the structured data. Like, you can represent all numbers as fractions, but how you getting 12? No? You know what I'm saying? I don't, I think that maybe their description of what this measure is wrong, and I'm just not familiar enough with it to be able to figure it out. Yeah, this is our explanation. Well, maybe there's an appendix. Although I would hope that if they talked about it in the appendix, they would, like, is it? Blue. Okay, so there's a little bit of tech discussion about blue. Are scores for domain-specific models. Yeah, and these range from like 40 to a half. and the blue scores. Oh, they do have some human evaluation. Okay, fantastic. I look forward to that. I don't see more discussion of what SCR is. So this is not a metric that I'm super familiar with. I don't know what a good range for it is. Based on their description of it as a fraction, I expected it to be, you know, sort of 0 to 1. Well, yeah, let's do a little search. Not error rate calculation. I have no idea, like, obviously 0 is good. 0 means no errors. Oft error rate. Nope. Step 1, spell the word good. Set error. Bunch of stuff about slot machines. Not super helpful for me. I'm just Googling in another window. Laser diodes. Don't think it's that. Bit error rate, satellite to ground communications. Also don't think it's that. All right, let's check out this paper. Okay, so here, another ACL paper. Tell me about these slot error rate calculations. So in the paper that they cited as having, as coming up with this particular metric, that paper cites another paper that they've already cited here, right? I'm pretty sure that they cited the one 2015. Yeah, here we go. Okay, so they cited the actual paper, and then they did not cite it at the place in the text where it was useful. So let's check out this. Oh, yeah. And this is from 2015, LSTM. Tell me about these SERs. Hmm. Equation. Appendix? All right. So slot error rate is defined as the number of missing and redundant slots over the number of total slots. So if I get a slot wrong, it's counted. And if I repeat a slot, it's counted over the number of total slots in exact matching in the given realization. Note that the ERR re-ranking criteria cannot handle arbitrary slot value pairs such as binary slots or slots that don't care value because they cannot be delexicalized and exactly matched. Okay, so what they're saying is that for every slot, this seems wild. So for every slot, this model adds or gets wrong 12 different slots. That seems extremely bad. That's like mystifyingly bad. That means that like just like random slot, well, no, yeah, they got to be random because they're not right. Slots are being generated at a prodigious rate. So I wonder if this is to help, this is like identifying, like sometimes NLG stuff has this problem where like it gets a little repetitious, particularly with language model NLG, where you'll have like something like I went to the park and fed the ducks and fed the ducks and fed the ducks and fed the ducks. So you'll have like something repetition like that at the end. And just like yeah, the range on this seems surprising to me. So what they're saying is that this system, right? So their very best system, for every slot, the slot is misidentified or repeated 40% of the time. Yeah? And for this one, for every slot, the slot is filled incorrectly or repeated more than once total. Enrique says nested citation. Yeah, that's a... If it's canonical to cite the paper that cites the paper, that's one thing. But if you're already citing the paper, I'm just going to assume that's an error on the D and W are nowhere close to each other though, so it's probably not like a LaTeX autocomplete error. Interesting. Oh, and then Jovan posted a link to the paper that we just looked at that I didn't see until too late, but thank you, I appreciate it. Okay, and then this model, multi-was, for every slot, there is a slot that is misidentified or repeated half a slot. For every total slot, the slot is misidentified or repeated. Yeah? N is the total number of slots in the DA. So my job title is developer advocate, and sometimes I have to dialogue act. Okay, so this is a per dialogue act measure. So in each dialogue act, for every slot in that dialogue act, this is the number of missing and redundant. That's so high. Okay. Well, so for multi-was, the three models that the authors propose, for every slot in the dialogue act, that slot is filled incorrectly or repeated more than once. And then this model has worse measures across the... Okay, interesting. Long since nice earrings. Oh, thank you. They are in Ojibwe strawberry design. There's a store in Seattle that sells signs by Native Americans. It's called 8th Generation if you're... Okay. Sorry, these error rates are astronomical. Like, so high. Like, I would never put any of these systems into production. These are research papers. To be fair, I don't think they're being like, hey, put these into production right away. Wowee. Okay. Basically, above 0 means I get it wrong more often. Sorry, above 1 means I get it wrong more often than I get it right. Okay, so this is on multi-was. This is on E2E. And these are all of these are metrics of language generation or machine translation. I think I've looked at Meteor and Rouge before. I'm not as familiar with NIST or Cider, but it looks like for all of these, up is good, and they're interesting. A lot of these systems have like exactly the same score for Cider and NIST. And then their sort of like fanciest system does not do as good on blue, but it does better on all of these other metrics, which, if I were cynical, I would guess that is why that's why they included them. But also, I do like to see more metrics, particularly for something where we know that the metrics are not the best match for a human evaluation. Andre says, O'Reilly has more pupils for money than are here for free. I'm not going to tell people how to do that. All right, interesting. So that's the story so far. I would like to see these other metrics also on the SGD dataset, especially since they talk about how this dataset is so much more difficult, and I would like to just like have more information, but there were also like a bunch of tables in the appendix, so it might be there. Okay, let's scroll. And we looked at this one. Yes, and again, this very interesting result where unseen slots are handled better than previously seen slots, which is surprising to me. Unless the unseen slots happen, well, okay, but this isn't a transformer-based model. I was gonna say, unless the unseen slots happen to have a, you know, closer match in terms of distribution to the training data for the transformer in the first place. Interesting. First, all models exhibit low SCR scores in both seen and unseen domains, with the template approach being the lowest. This suggests that pre-trained that they're good at copying. Schema-guided representation performs on par with the naive representation as seen on domains. At the same time, the slot descriptions do improve performance on the unseen domains, albeit to a limited degree. This is where we're describing what's in the slots. More effective ways of incorporating descriptions is a promising area for future work. For the seen domains, T2D2 outperforms naive by 1.7 blue. Results on unseen domains are striking, with an improvement of 7.3 points. This confirms the hypothesis that our simple template-based input scheme offers superior generalization capabilities with a low overhead. The template model learns to fuse sentences and is able to successfully extend this skill to unseen domains. Interesting. Okay, so I think that's where we're going to call it for today, because it's a little past 6 already. And I will say there will be no paper reading group next week because it is Thanksgiving in the United States, so I'm going to be off. And there will also be no Friday live stream next week. Again, Thanksgiving, I'm off. So we will pick up with this in 2 weeks. Thoughts? I just can't get over those slot error rates. Like, I will say, I don't read a lot in the natural language generation literature, so I don't know what like a good range of scores is. But like, I want it to be 0, you know? Like, I don't want any errors when I'm telling people pieces of information, you know what I mean? And it could be that like it's a pluralization mismatch or something like that, or that it didn't work for Boolean slots. It didn't work for like things like true false, which I don't know why, but I guess I trust the authors, because also the people who in the Wen et al. 2015 paper, they also said that, so I guess that's true. Yeah, I might actually just like tweet about that. Like, what's a usual score for this slot error rate measure? Because that is fuck wild. Anyway, yeah, we will come back 2 weeks tomorrow. We're gonna have live coding. We're gonna be continuing to work on adding a database to our assistant. Have I shared that code on GitHub? I sure have not. Let me add that to my notes. Um, and this afternoon, I'm actually going to be at a panel in an EMNLP in the negative results workshop, just sort of about stuff. So if you are interested, that's happening. I think I've retweeted it, so it's on my Twitter, RCTATMAN, if you're add live coding code. It's on GitHub, I just need locally, I don't remember, I'll deal with it. All right, so have a great day. I will see you maybe at the panel, maybe tomorrow morning, or maybe on the Rasa forums, and I will talk later. Yulong says, what's the next paper? It's gonna be, we're gonna keep going on this paper, and I'm gonna see if I can learn more about this slot error rate, because that is 12. How is it 12? And then looking, because it's not like of the slots generated by the system, it's of the slots per utterance, right? Like it gets 12 wrong before it gets one right. Or here, it gets like 42 wrong before it gets one right. Is this like a good range? Like this is bonkers. Like if you told people that there was like ASL interpreting at a concert 20 times before you were right about it, that would be absolute. Anyway, my interest is piqued, and I would not, based on these error rates, recommend you put these systems in production, but also I don't know that the authors are necessarily recommending that anyway. All right, as banana. Anyway, I'll see y'all tomorrow. Have a great day. Wash your hands. Stay safe. Oh, and I'll talk to you later. Bye. Mask.